Hello Year 5 and welcome to your maths lesson today. I hope we got on okay with the maths lesson yesterday. Today's lessons might help make yesterday's lesson make a little bit more sense to you if we got a little bit stuck with how to convert some of our fractions, okay? But we will have a go and see how we get on, okay? So we're going to warm your brains up first with some multiplication and division facts. So put a timer on, 5 minutes, pause the video, have a go at these questions. So 34 multiplied by 27 using our multiplication here, 918. Now a book costs £19. We need to know how many does 9 books cost. So that means we need to multiply 19 by 9. Now equally, you could do 20 times 9 and then take 9 off. And that's going to give you 171. Okay, that way you don't have to do any multiplication at all. Now complete the sentence. 8 is a factor of what? Now we know that multiples are good, bigger, factors are smaller, good. So it's got to be a number that is smaller than 8. So it's wherever the 8 appears in some of the times tables. So you could have 16. It could be 24. Okay. If you've got any other examples of the 8 times tables, then that is fine. What is 48 divided by 3? The answer there is 16. Okay. So have a go at these ones as well. Okay, these are some of our division facts and fractions work for this week. Okay, so for today's lesson. So again, pause the video, give yourself 5 minutes, see if you can have a go at this question. So 24 divided by 4, well that's easy, that's our 4 times tables, that gives us 6. How many tenths is in a whole? So it tells us if it's tenths, we need 10 lots of 10. So the answer there is going to be 10. But now I need how many tenths are in 2 wholes. We need 2 lots of tenths. Well, I know that 2 lots of tenths is 20, so I must need 20. And how many hundredths are in 5 wholes? Well, I know that 1 whole has got to be 1 hundredths. 2 wholes must be 2 lots of 100. So 5 wholes, therefore, must be 5 hundredths to make a whole, or 5 hundredths to make a whole. So well done if you got those correct. So we're going to be looking at improper fractions today. Okay, so here we're going to start off with this question. So here we have 7 over 7. And here we have only 2 sevenths. Okay, so altogether, if we added up the amount of sevenths that we had, we've got 14 in total. Okay, so we've got 14 altogether, but only 9 of them out of the 7 are shaded. So that tells us that there are 9 sevenths altogether. And you'd write that as a fraction as 9 over 7. Same for this one here. So here we've got 7 sevenths, which is 1 whole, and this is your 2 sevenths, okay? So here we've got 9 sevenths altogether. So that means that 9 sevenths is the same as 1 whole, which is 7 sevenths, plus an extra 2, so 2 sevenths. You'd write it as 1, and then the fraction 2 over 7. I'm going to show you some more examples of how to write them further on. So let's have a look at this one then. So here we've got 2 sixths, and here we've only got 5 sixths. Now I don't see a whole bar that's shaded in. But if I count them all together, I have 1, 2, 3, 4, 5, 6, 7. Now that's more than my denominator. So I should be able to move some of these, okay, and move them so that they make a whole. So yes, I have 7 sixths altogether, but I still have a whole one because I've got 6 out of 6 that makes a whole. And I have that 1 extra one. So here I have 1 whole and I have 1 sixth. Okay, so 7 sixths is the same as saying 1 whole and 1 sixth. And that's what we call a mixed fraction. But don't worry about that for today because we'll do that in another lesson. So what I need to do is pause the video and see if you can have a go at doing these ones on your own. So think about how many fifths there are altogether. So that's the ones that are shaded. Okay, and then you need to think, well, that number of fifths is the same as how many wholes. So how many whole lots of 5 can we fit along these ones? And the same goes for these 2 halves here. So see if you can pause the video and have a go at filling in the gaps. So all together, okay, we've got 5, 6, 7, 8, 9, 10. We have 11. Okay, now we know that in fifths you have to have 5 equal ones. So if we count in our 5s, we do 5, 10. So now I'm going to get 2 whole lots of 5. Okay, so I've got 2 wholes, but then to get from 10 to 11, I have 1 left over, which means I have 1 extra fifth. So 2 wholes, because 2 times 5 is 10. And then to get to 11, I have that extra one. So it's a bit like doing our remainders. So we know our multiples and we have our remainders. So here we've got how many halves? Well, I can see 1, 2, 3. It's got 3 halves. So 3 halves is the same as 1 whole, because I know that 2 halves makes a whole. So I've got 1 whole and then I've got 1/2 left over. Okay, so those are my missing numbers. So as long as you know your times tables, you can work out that if I've got 11/5, that means that 2 of them must be whole, because I can fit 2 whole groups of 5. So I can fit 5 and 10. And then that extra one left over, which is my remainder, would be your fraction. Okay. So based on that, we'll have a go at doing questions 1 to 2 on your worksheet, and then come back and we'll look at some more questions. So here we have 12/6. So this is what it looks like when we write it as a fraction. So when we look back at the 11/5ths that we've had the 3 halves, that tells us that the numerator, so the top number, is the biggest number. So not the denominator, not the bottom number this time, but our numerator. And this is what we call an improper fraction. It's not a proper fraction, because it's what we call as being top heavy, because that number on top as the numerator is bigger than our denominator. So we actually write it as an improper fraction. Okay, so let me show you an example from one of the ones we've done. So here we've got our 6. So here we've got 6 6s. Okay, so 6 makes 1 whole. Okay, imagine that was 1 whole pizza cut into 6 pieces. Okay, that now makes a whole with all pieces attached. Here I also have another 6 6. So I've got another 6 slices of a whole piece of pizza. So altogether I have 2 wholes. Okay, so 12/6 is the same as saying I have 2 lots of 6. I have 2 whole pizzas cut into 6 pieces each. So although I have 12 pieces altogether, those 12 pieces have come from 2 whole pizzas. So if we look at this one for 18/6, okay, we know we need them in groups of 6 and equal parts. So I know I can do the first 6, that's 6 6. I can do another 6, okay, that's another 6 6s. So now I'm on 12/6. And now if I fill out another box of 6 6s, that gives me 18, because 3 lots of 6 gives me 18. So I can see here, if I was doing some pizzas now, I've got 1 pizza, 2 pizza, 3 pizzas. So 18 slices, okay, if I put them back into their whole pizzas, would give me 3 whole pizzas. Therefore, 18/6, so 18/6 is the same as saying 3 wholes. Okay, so let me show you how we work that out. Okay, and I know some of the children yesterday, like Keaton, we went through this. It's all about looking at how we multiply and divide our denominators and numerators. So here we've got 18/6, and we know that's 3 wholes. So we need to think, well, how do we know that that's 3 wholes? So what you have to think is, how many times can I get the denominator into the numerator? So how many groups of 6 can I get into 18? So I do 6, 12, 18. Oh, well, it goes 3 times. So that means I multiply it by 3. And we know that we're multiplying because we're going from a smaller number to a bigger number. So we know that we have to multiply. Now, if we have to multiply from the smallest to the biggest number, and maybe we didn't have the denominator, how would we work out how we got from 18 to 6? Because we multiplied the first time round, but now we're going from a bigger to a smaller number. So what operation do I need? Good, I need divide. So on the other side, you're going to divide it by 3. So thinking, well, hang on, how many times can I divide 18 by 6? Well, I can divide it 3 times, because we're going from a bigger to a smaller number. Okay, so that tells me that 18 is 3 times bigger than 6, because 3 times 6, okay, so 3 times 6 gives me 18. Let's have a look at it in some other questions to show you how it works. So here I've got 5/20ths. Well, I'm thinking to myself, how many times can I get 5 into 20? So we do 5, 10, 15, 20. Oh, well, I can divide it exactly 4 times. So let's check that. If I have my 4 lots of my whole parts, so I've got 1 part of 5, 1 whole part of 5 here, 2 whole parts, 3 whole parts, 4 whole parts. I now have 4 lots of my 5. And if I count them all together, that gives me 20 pieces. So I have 4 wholes in comparison to having 20 pieces. So if I now had 20 slices of pizza and I put them back together, it would give me 4 whole pizzas, because I know that 20 divided by 5 gives us 4, but I also know that 5 times by 4 gives us 20. Okay, with me so far? So let me show you them. So we went from 5 to 20, we multiplied it by 4. Equally, we checked that 20 divided by 4 also gave us 5. And that tells you how many wholes we can get, because there's no remainders at this point in time. Now this one, it's slightly different. Okay, so it's still an improper fraction because my numerator is bigger than my denominator, and I'm looking to separate them into groups of 6. So let's show our equal bars of 6. So here we have a whole pizza. Okay, we're imagining this is all pizza. I'm very, very hungry. So this is our whole pizza, and it's 6 slices. Now I have 10 slices. So I need to get another pizza, and it's also cut into 6 pieces, but Miss Humphrey is only going to eat 4 of those. I'm going to only eat 10. I mean, yes, okay, judge me. I ate a pizza and 2/3, but leave me alone. I was hungry. So here I've got my whole pizza up here, and then I've got my 4 extra slices. Okay. Now, I don't have 2 wholes. I now have a whole pizza that I've eaten. Then I've eaten part of a pizza, and I've left some of the slices behind. Okay. So now I need to work out, well, now how do I write this as a fraction? So here I've got 4/6. And now I've got 6. And if I add my numerators together, that gives me 10/6. That's 10/6. So I have 1 whole. But then I need to count the fraction of what else is shaded. So I have my 1 whole here, but then I've got 4/6. So I need to add the 4/6. And I'd write that with my fractions. So I'd do my big 1, and then I would write my 4/6. So that tells me I've got 1 whole and 4/6. Because if I think about it and divide them, I can get 6 into 10 only once. 1 times 6 is 6, well, 1 whole. But then I need to think, well, what's left over from 6 to 10? Well, 7, 8, 9, 10. Got 4 left over. So that means I have 4/6 left over. Okay. So based on that now, I want you to have a go at doing these ones. So think about the same process that I've looked at. Think about, well, how many 3s are in 11? Do we do 3, 6, 9? Okay, we can't go any further than that. So now it's got to be 3 wholes. Then you think, well, what's the remainder? So think about the wholes and remainders that we've been doing for our division beforehand, and that will help you. So always remember, divide your numerator, denominator by numerator, or think, how many times can I get my denominator into my numerator, and then think what's left, okay? So pause the video and have a go. So we know we have 3 wholes, okay, so we've got 3, 6, 9. From 9 to 11, we have 2 left over, so 2/3. Here for the wholes, we've got 2, 4, 6, 8. Well, we can't go any further, so we've got 4 wholes. And then we want to get from 8 to 9, there's only 1 left over, so it's 1/2. And here we have 7, so 7, 14. Well, I can't go to 21, so I can get 2. So I've got 2 wholes. And I was at 14. 2 times 7 is 14. So how do we get from 14 to 6? Well, that's left. Oh, it's 6 left over. So that tells me we've got 6/7 left over. Okay? So all you need to know is your times tables knowledge. You know your times tables, you'll be fine with these today. Okay? So let's explore these ones here. So is 7/2, so 7/2, bigger or greater than 7/5? Okay, so if we look at these into our shapes, okay, we can see here that actually that 7/2 is actually bigger. And the reason why it's bigger is if the numerators are the same, then we look at the denominators. The bigger that denominator, the smaller that piece is going to be. So imagine if I had a whole pizza and I split it into half, I'm going to get 1 big piece. But if I've split that pizza into 5, I'm getting a smaller piece of that pizza each time. Okay, so remember that one as our rule. So same goes for this one. So we've got 24/6 and 16/4. If we put these out into our boxes, here we've got 6, 12, 18, 24. And here we've got 4, 8, 12, 16. Now, if I sound those out, they all fit equally, don't they? And there's 4 times that I can get both those numbers in. 4 times 6 is 24, and 4 times 4 is 16. So that tells me that they're equal to each other. So pause the video and see if you can have a go at this one. Okay, so 2 wholes and 3/5. I'm going to show you what that looks like. So there is 2 wholes, okay, and 3/5. And then we have 9/5 over here. So that's how we write those fractions. So for this one, 2 wholes and 3/5 is going to be bigger, okay? Because we've got more wholes than we have from the fifths. When we look at the 28/7 and 2/3, that's what this one looks like, okay? So we've got 28/7, and then we have 12/3. So that thirds tells me that that's going to be my denominator, okay? So if we look at those as our fractions, we can see they're actually equal to each other because we can equally divide our denominators into those numerators. Now, it's done it for you here already. So 9/6 and 17/8. So you think, well, how many times can I get them into each other? Well, actually, 8 into 17 is going to be bigger, okay, because I have that remaining one left over. And then 20 tenths and 20/9. Well, we already know which one's going to be bigger because this number here is smaller, which means the portion they're getting here is going to be a lot smaller, okay? Well done if you got those right, because those ones are difficult ones. But based on that, have a go at doing questions 3 to 6 and see how you get on, okay? Remember to try and rewrite your fractions to help you. And if you get stuck, go back and pause the video and have a look about how we multiply from the denominator to the numerator and how we divide from the numerator down to the denominator. So have a go at those questions and we'll see how you get on. Okay, good luck, year 5.